Okay, so we finished on Tuesday talking about ionic compounds and their names and formulas. So now we're going to talk about molecular compounds. Molecular compounds are generally composed of two nonmetals, and because there are no ions with charges, we can't figure out how many atoms of each element there are just, by the charges or anything. And many of these combinations, like nitrogen and oxygen, form more than one compound. Sodium and chlorine only form one compound, sodium chloride. But nitrogen and oxygen form 6 unique molecular compounds listed here. We cannot predict which one we're talking about just from the element names, and we need a name for each of these compounds that's unique and descriptive. So again, molecular compounds are composed of two nonmetals. We use numerical prefixes to indicate how many atoms of each element are present in a molecule. So the prefixes are over here, the same as what we use for the hydrates, with the exception that we don't use hemi because you can't have half of an atom in a molecule. The more metallic element is generally listed first. Usually this is the element with the smaller smaller group number. You really don't need to worry about this distinction too much, but sometimes students are curious, well, why is it H2O and not OH2? And that's because in terms of metallic character, hydrogen is more metal-like. And so just like with the ionic compounds where it's the metal and the nonmetal, with molecular compounds it's the element that's more like a metal that goes first, just because we decided to do it that way. So the pattern for the names here is that we use a prefix, one of those prefixes on the previous slides, to indicate how many, and the name of the first element. And then there's a space and a prefix and the name of the second element with the ending changed to "ide." So there's some similarities between molecular nomenclature and ionic nomenclature. The first element doesn't do anything to the ending of its name. The last element changes the ending of its name. If there's only one atom of the first element, the prefix mono is normally omitted. So NO2, following this pattern, would be mononitrogen dioxide. But for the first element only, we usually eliminate the mono, just because. And then there are two compounds that always use their common names, and you need to know these: water and ammonia. Probably don't have too much trouble remembering water is H2O. Ammonia is NH3. And that is similar to ammonium is the ion NH4+. So ammonia, ammonium, NH3, NH4+. Related but not the same. Any questions? So let's practice a little bit. Name this compound N2O5. Well, we're going to use prefixes to indicate how many. So what's the prefix for 2? Di. So that first element is nitrogen, so we're going to write di-nitrogen. And then what's the prefix for 5? Penta. Penta-oxide. So the warning I'd like to give you is that students like this system of naming so much that they want to use it for everything because it's just easier, right? It just makes so much sense. Why can't we use it for everything? Well, because we can't. So make sure that you're only using this with two nonmetals. If that first element is a metal or there's more than two elements, you can't do it this way, okay? Let's write the formula for phosphorus tribromide. What's the element symbol for phosphorus? P. And how many are there in this molecule? Just one. It doesn't say mono, but it doesn't say anything else, so we're going to assume one. And then tribromide is how many of which element? It's 3 bromines. So Br, the subscript 3. I know that some people do not have very good penmanship, right? And that's fine. It needs to be legible, and you need to take a little more care when you're writing formulas, because this 3 needs to be a subscript. Sometimes I see things like this, and it gets a bit confusing. So just do your best with the chemical formulas. I guess there's one other thing I should say about these guys, or maybe 2. What's the name of this? Is carbon monoxide. So there's 1 carbon, but because it's the first one, we don't say mono. And then here, if we go monoxide, we see that looks a little weird with the double O thing there. We often, but not always, drop that last vowel on the prefix when the element name begins with a vowel. So I'm not going to grill you on this. If you wrote monoxide, I might cross off the extra O, but I wouldn't mark it wrong. But I want you to just be aware of this so that if you see monoxide, you don't say, ooh, that's spelled wrong. Other times we leave them together, like triiodide. We really need the double I's there. And so some students, do find that a little disturbing, but just do your best. And I'll accept either way, but I'll just correct it. Another thing, I see this, and I don't know. Let's see if I can think of an example that's not the example on the worksheet. I don't know if this compound exists, but we could name it. So how many sulfurs? 2. So disulfur tetrafluoride, right? What I see, and I don't know where it's coming from, I don't know if there's a tutor or it's just a bad rumor or a bad YouTube video or something going around. Sometimes I'll see students look at this and say, well, I can reduce that from 2 to 4 to 1 to 2, and they'll say that's sulfur difluoride. We don't want to do that. This is saying that there are 2 sulfur atoms and 4 fluorine atoms in one molecule. We are not looking for an empirical formula here. You just write the name based on whatever the formula is, even if the numbers seem really huge and crazy. That's what we gave you, just name that thing. And I'm telling you this because there's a compound in the worksheet we're going to do today where a lot of students reduce the ratio here, and you do not do that with molecular compounds. Okay, we're not looking at empirical formulas, we're just naming what's given. Okay, I will mark that wrong. Okay, so acids. Acids are also molecular compounds. There are several different definitions of acid, but one is that an acid is a molecular compound that releases hydrogen ions when dissolved in water. So acids are composed of hydrogen and then 1 or more nonmetals. So the hydrogen is usually written first in their formula, and in Chem 1A it's always written first in their formula. So we see a formula like HCl. This is an acid. We identify that this is an acid because it starts with H. So if it starts with H, it's going to be an acid in Chem 1A. This is a molecular compound. Hydrogen is a nonmetal. Chlorine is a nonmetal. It's a molecular compound. But when it's dissolved in water, it forms ions. Those ions are H plus and Cl minus. And when we put this AQ in parentheses after the formula, that means it's dissolved in water. If you had a compound that started with H but didn't dissolve in water, then it would not be considered an acid. If you want to be really picky, HCl in its pure form is a gas, and that would be named as a molecular compound. HCl dissolved in water is an acid and is named as an acid. I'm going to ignore that in this class. It's there, but it's easy enough to figure out later when you need it. If you see something that starts with H, name it as an acid, okay? So characteristics of acids. Acids taste sour. If you think of a food that tastes sour. Oranges, they're acidic. Lemons, acidic. Sour candy. You know what makes it taste sour? That stuff on the outside that looks like sugar has acid in it. Not the drug acid, but an organic acid derived from fruit, like malic acid or something. And that's what makes it taste sour. So it has a sour taste. We're obviously not going to taste the acids in lab. Acids also will dissolve many metals. Zinc, iron, magnesium. Metals like gold, silver, and platinum do not dissolve in acids. Now, do you remember the experiment we did on Tuesday? What did we start out with? Piece of copper wire. And what liquid did we put on it? Concentrated nitric acid. And what happened to the copper? It dissolved, right? It seemed to disappear. It dissolved. So that's an example of an acid dissolving a metal. Here's an illustration of another one. This is zinc metal in hydrochloric acid. And the bubbling that we see here is hydrogen gas being formed. Wait, did I miss something? Formulas generally start with H, yeah. Okay, so there are two basic types of acids, and they have different patterns for their names. So oxyacids, as their name suggests, are acids that have oxygen in them. So if you see a compound that starts with H and it's got an O in it somewhere, it's an oxyacid. And the other acids are generally called binary acids. They only have two elements, except for the one that, I don't like this name binary acid. I prefer to think of them as the oxyacids and the others. But the book uses binary, so we'll go with that. So binary acid, hydrogen and a nonmetal, oxyacids, hydrogen and an oxyanion. That oxyanion is going to have oxygen in it. So those binary acids, we use the prefix hydro at the beginning. You can think of this as standing in for the hydrogen at the beginning of the acid name. And then the middle part is based on the name of the other element that's in that acid. And here, instead of changing the ending to "ide," we change it to "ic," and we add the word acid. So if we look at this, HF, you see any oxygen in there? No. So this is a binary acid. So we see the hydrogen, we write hydro, and F stands for fluorine. So we're going to change the ending to ic, fluoric, and the word acid. Common misspelling of fluorine. Fluorine. There's no flour in fluorine. Fluorine is gluten-free. It actually is, because it's just an element, right? But if that helps you remember, there's no flour in there. It's UO. So hydrofluoric acid. What if we have a name and we're going to write the formula? Hydrosulfuric acid. Well, the word acid here is a dead giveaway that this is an acid, right? So we've got hydro, that's going to be hydrogen. And sulfuric is which element? Sulfur. So how do we know how many hydrogens and sulfurs to put together? Well, when this is dissolved in water, it forms ions. What ion does hydrogen form? +1. We remember that because hydrogen's over there with group 1. It's not an alkali metal, but it forms a +1, and that's why it's over there. And then sulfur forms what kind of an ion? 2-, right? So this is not an ionic compound, but it forms ions, and so we can use the charges on the ions that it forms when it dissolves in water to predict what this formula is. So if this is a -2 charge, how many hydrogens do I need? 2 of them. So the formula is H2S. And naming this as an acid, it's best if we put AQ behind it, just to avoid confusion. Any questions? There's only a handful of binary acids, because there's only a handful of nonmetals over there. So we'll see acids form with, could form with nitrogen, phosphorus, sulfur, fluorine, chlorine, bromine, iodine, possibly selenium. That's it. Then the other ones are the oxyacids. There's a lot more of these. So these have oxygen in them, and they are named based on the oxyanion that's present. So we look at the acid, cover up the H, and the rest of it looks like an oxyanion, but the charge isn't written there. So we find the name of that oxyanion and change the ending of the ion name from 8, if that's what it ends in, to ic. If the ion name ends in ite, we change it to us and add the word acid. So there's a couple ways to remember how those 4 things pair up. Rick ate him before he could bite us. So here's the ick and ate, ite, and us. I know, right? The weirder, the stranger the sentence, the better you remember it. Another one that a lot of students use involves a mouse. The white mouse ate icky cheese. Same idea here. Here, ate icky, white mouse. Okay. So ite and us go together, ate and ick go together. So let's look at that. So name the acid HNO2 aqueous. So we recognize this as an oxyacid because it starts with H and there's oxygen in it. So we want to cover up the H and we see NO2. Okay. NO2. And so the name of that is nitrite. So that's nitrite ion, and what's the charge on the nitrite ion? -1. So we know the name and we know the charge because we memorize it. Okay? So the charge on this ion is going to tell me how many hydrogens I need, because it's that ion and hydrogen ion. So a -1 and a +1, I just need to write them together. That's where I get the HNO2. So naming this, I'm going to change ite to us. Whoops. So this is nitrous acid. These are very nice patterns, but you need to take some time to learn the patterns. Let's do it the other way, right? The formula for perchloric acid. So I can tell that this is an oxyacid because it does not start with hydro. It's an acid because it's got the word acid in it, right? That's usually no problem. It's an oxyacid because it does not start with hydro. So perchloric, what do I change the ic to? The ic goes with 8. So this has got perchlorate ion is what it forms. Perchlorate ion. Well, what's the formula for perchlorate ion? Cl(O4) with a -1 charge. We memorize that chlorate is ClO3 minus. Perchlorate has an extra oxygen, same charge. So about the extra? So chlorate is ClO3 minus. We just memorized that one. And perchlorate means it's got an extra oxygen. The charge is the same. Nitrite is one less oxygen than nitrate. So ClO4 minus, the other ion is going to be a hydrogen ion. And so when I put these together, my formula is HClO4, and then ideally we put AQ after it. Any questions? So we kind of already did this, but here's written out instructions. When the name ends in acid, the formula is going to start with an H. You write the formula as if it was ionic, even though it is molecular, because it forms ions. The hydro prefix tells us it's a binary acid. If there's no prefix, it's an oxyacid. For the oxyacids, if the ending in the acid name is ic, then the polyatomic ion ends in ate. If the ending is us, the polyatomic ion ends in ite. So this kind of a slide might make a good screenshot to have on your phone, right? A lot of these slides are like, yeah, you don't ever need to look at that again. But some of them kind of summarize some useful things. And, I often see students taking pictures of the screen, and I guess that's okay, but you can also go on Canvas and pull up the actual slides and have a really nice screenshot of this. And then when you need to look at it, you can just pull it up on your phone. Some extra examples. Write formulas for the following acids. Hydrocyanic acid. So is this a binary acid or an oxyacid? It's binary. We can tell because it starts with hydro. So it's going to be H, hydrogen ion, and something else. And cyanic acid, what does that come from? Cyanide. Is cyanide an element? No, it's an ion, right? Cyanide is Cn minus, because it's on the list and you memorize it. So the formula for this acid would be HCN aqueous. And that's the acid that makes me not like the term binary acid. How many elements are in that one? 3. That's not binary. But there it is. Okay, this one, phosphoric acid. Oxyacid or binary acid? Oxyacid, because we have no hydro. So then we're going to look at phosphoric. We're going to change the ic to 8. So this comes from phosphate. You're like, well, why isn't it phosphorate? Well, sulfur and phosphorus, this vowel or this syllable here kind of comes and goes, just seemingly randomly. And that's another thing that I won't take points off for, but I will correct you. So this is phosphate. That's this or syllable just kind of disappears. So phosphate, what's the formula for phosphate? PO4 3 minus. So most of you did quite well on the memorization quiz, but you can't just now let all of that go. You should keep reviewing it because this kind of thing is going to show up for the rest of the semester, okay? So keep using the quiz on Canvas or make some flashcards or use a flashcard app on your phone or something. So when we need to know what the formula for phosphate is, we should first search our brains and take our best guess at it and then double check by looking at a list or something. So that's phosphate. And then there's going to be hydrogen. So how many hydrogens do I need? I need 3, so this will be neutral. So it's going to be H3PO4. Okay? So let's just talk for a minute about the phosphate ion, the hydrogen phosphate ion, and the dihydrogen phosphate ion. So this is actually what's called a triprotic acid. A hydrogen atom has 1 proton and 1 electron. To make the hydrogen ion, you lose the electron, and what's left? A proton. A hydrogen ion really is just a single proton. And so it's often, we use the protic instead of saying hydrogen. So triprotic meaning 3 hydrogens. These hydrogens can come off one at a time. So here's the acid, and if it loses one of its hydrogen ions, we get H2PO4. If it loses 2, we have HPO4 2 minus, and if it loses all 3, we have PO4 3 minus. And so we will sometimes see these other guys, like with sodium or something. And so it's phosphate, this is hydrogen phosphate, and this is dihydrogen phosphate. And sulfate and sulfite do that as well. We'll see hydrogen sulfate. Hypochlorous acid, binary or oxyacid? Oxyacid. This prefix hypo looks a lot like hydro, but it isn't. So hypochlorous comes from what ion? Hypochlorite, right? So chlorate is ClO3 minus. Chlorite is ClO2 minus, and hypochlorite is ClO minus. This is chlorate. That's the regular one. This is the light version with 1/3 fewer oxygen atoms. And this is whoops. Oh, I'm having all kinds of trouble now. Hypochlorite. And the charge is -1, and so to make the acid, it's HClO.
So if it was on ClO4, it'd be her?
Yeah, so ClO4 minus is perchlorate. And so we could make an acid with all of these. This would be perchloric acid, chloric acid, chlorous acid, and hypochlorous acid. Any questions?